A brief overview of applications of oscilloscope in the medical field, daily medicos. What is an oscilloscope? Applications of oscilloscopes in the medical field are vast. The oscilloscope is also known as O-scope or CRO for cathode ray oscilloscope, or DSO for digital storage oscilloscope. It was previously known as oscillograph. An oscillograph is a type of electronic test instrument that represents or displays the varying signals voltages graphically, as a calibrated two-dimensional plot of one or more signals as a function of time. The following properties can be analyzed through the displayed waveform: amplitude, frequency, rise time, distortion, time interval. 1. Display. Graphical representation of an oscillograph displays voltage values on y-axis and time on x-axis. This graph enables us to assess the peaks at various points of the waveform, i.e., potential values at particular times. Determine how long one rhythm of the wave is, i.e., the waveform's period. Correlate the distinction in the distance covered by two waveforms that started at the same point, i.e., their phase difference. 2. Control system. An oscillator has 4 different systems to assist function. Vertical system. It controls the size and location of the waveform in the vertical direction. This system assists with conditioning the input signal. Horizontal system. It controls the size and location of the waveform in the horizontal direction. It helps with capturing the signal. Trigger system. This system ensures that the initial point of the wave pattern is properly placed on the screen. Display system. It consists of the display screen, knobs, buttons, switches, and indicators on the frontal panel. An oscilloscope is a modern electronic device in medical fields with a lot of significance. There are multiple uses of oscilloscopes in the medical field with numerous advantages. The significance and purpose of oscilloscopes in the medical field can be highlighted as follows. 1. Medicine. An oscilloscope is used by health workers to monitor the patient's heartbeat and brainwaves. It enables health care professionals and staff to see the rhythm of heartbeats instead of seeing it. Graphical representation by this instrument is used to monitor the electrical activities of the heart. Medical and laboratory technicians used oscilloscopes for diagnostic approaches. 2. In research field. Research scientists and physicists used oscilloscopes for a variety of purposes. For example, it is used to examine the effect of various neighboring variations regardless of television and cell phone signals. The spectrum is fundamental testing equipment for investigators in diverse fields. Physicists utilize an oscilloscope to graphically illustrate a vast range of microscopic electrical signals too large. An oscilloscope can pick up the information and maintain it for a precise time or store displayed signals for later evidence. 3. Power analysis. Oscilloscopes can be utilized to quantify and analyze the processing characteristics of circuits, power conversion devices, and line power harmonics. Special software and differential amplifier probes are needed to make analysis easier with more accuracy. 4. Serial data analysis. In serial data analysis, oscilloscopes are helped to evaluate and define such data patterns as USB, SCSI, fiber channel, firewire, rapid I/O, InfiniBand, Ethernet, serial ATA, Bluetooth, and CAN bus for the automotive industry. Oscilloscope works by capturing digital data signals that are moving to ever-increasing data formats. 5. Time domain reflectometry. An oscilloscope is used in time domain reflectometry, which is a method to determine impedance values and variations or faults along with transmission cables, cable connectors, or microstrips on a circuit board. Types of an oscilloscope. Oscilloscope has 4 main types which are subdivided according to the updated versions and specifications. These are briefly discussed as follows. 1. Digital storage oscilloscopes. Digital storage oscilloscopes, or DSO, are the most preferable equipment for industrial applications. It used digital memory to store data as long as required without any loss or degradation. DSO also enables complex processing of the signal by high-speed digital signal processing circuits. DSO allows the storage of data in internal or removable storage. It has vast applications in other specialized fields like telecommunications, as it offers numerous features such as frequency spectra, statistics, and histograms. Other advancements in digital oscilloscopes include the following: digital sampling oscilloscopes, handheld oscilloscopes, PC-based oscilloscopes, mixed signals oscilloscopes. 2. Cathode ray oscilloscope, CRO. It is one of the simplest and earliest types of oscilloscopes and is now termed analog to differentiate from digital oscilloscopes. It comprises a cathode ray tube, a vertical amplifier, a time base, a horizontal amplifier, and a power supply. This basic structure remained the same even in the advanced and upgraded version of this instrument, although a CRO authorizes one to examine a signal. In its primary form, it has no factors of recording that signal in black and white for the purpose of documentation. Thus, specific oscilloscope cameras were promoted to capture the screen instantly. Other advanced features of the oscilloscope are: on-screen feature of time-base settings and amplifiers, adjustable horizontal lines with voltage display through voltage cursors, adjustable vertical lines with time display through time cursors, on-screen menus for trigger settings and alternative operations, an electronic survey of potential and repetition of a represented trace. 3. Analog storage oscilloscope. Some analog oscilloscopes offer the additional feature of case storage through direct view storage (CRTs). Instead of normal decays in a fragment of seconds, this storage allows the trace pattern to remain on screen for several minutes or longer. An electronic circuit can later be consciously stimulated to save and delete the trace on the screen. Analog storage oscillators may use different types of storage forms such as bistable storage, storage AR phosphor, etc. Storage oscilloscopes are associated with one or more electron guns to provide a steady flow of low-energy electrons towards the phosphor screen. Flood guns are excellent for this purpose as they cover the entire screen, so in this manner electrons from fluid guns re-illuminate phosphor in the positively charged area of the screen. 4. Analog sampling oscilloscope. It was developed as a conventional oscilloscope to fulfill the needs of scientists to capture the waveform of the very fast repetitive pulse. Analog sampling oscilloscope offers an effective bandwidth of 300 MHz and represents considerable advancement. Sampling oscilloscopes produce their broad bandwidths by not picking up the full signal at a time. Instead, merely a fragment of the signal is picked up. The specimens are then collected to produce the waveform. This approach can particularly serve for repeated signals, not transitory events. The concept of sampling can be figured out as a stroboscopic technique. When adopting a strobe light, only pieces of the motion are recognized, but when adequate of these photographs are collected, the overall motion can be captured.